what sort of aircraft is this, and when did you start producing them? Where did design come from?
Okay, so, well, this is an AirCam. This particular one behind us is on floats. It's amphibious. The first AirCams were not on floats, they were on wheels. AirCam number 1, we built in the mid-90s, and it was designed for a National Geographic research project in northern Congo, a rainforest called the Ndoki rainforest. They were trying to get this rainforest made as a park to protect it. And they wanted to bring light to their, what they were trying to do. They didn't have much space to operate out of. In the end, we ended up with a 600-foot strip, a very tiny little airstrip, one way in, one way out of the rainforest. And so we built that first airplane for them. There was really no chance of rescue if we were to go down out there in the rainforest. And so the twin engine thing was kind of important.
Yeah, because it's a safety sort of thing, yeah.
We wanted to be able to fly low. We wanted to have that redundancy. And once we went out over the rainforest, it was almost like going into outer space. Because if your equipment didn't bring you home, you weren't going home,
yeah.
Right? So we built that one. It worked really well. Their mission was successful. The Ndoki rainforest became a national park and it's protected. And eventually that AirCam was shipped back to the US and restored sometime after that. And it's in the EAA Air Museum in Oshkosh, Wisconsin, AirCam number 1. So you can actually go and see that in the Air Museum.
Wow, so it's like a history piece now.
It is, yeah. We built one more prototype like that AirCam 1. We call that Generation 1 as well. And we showed it at shows and there was a lot of interest. So we decided to go ahead and make it into a kit plane and fully engineer it. So about 22,000 hours of engineering later, we had what we call Generation 2, which is actually what this AirCam is, and it's what most AirCams are. We built those for quite a few years, from about 2000 until 2020. And then we came out with the Generation 3 AirCam. And that has a stronger fuselage, higher gross weight, stronger landing gear, tail wheel, a few changes to the wing. And we were able to increase the gross weight from 1680 up to 1900 pounds. And then in the changes, we also added a third seat and all the seat belt attachments. And so it became a true 3-seater.
So what about the gross weight? Do you need both engines to be able to take off with it fully maxed out? Or can you take off on just one?
Well, we don't recommend taking off on
Yeah.
We do demonstrate it. And as long as you have the appropriate engine for the weight that you're flying at, it will perform well on one engine.
So with 2 engines, what's the sort of aircraft type? Like, is it classified as an ultralight? What is it classified as?
Here, it's a twin engine airplane. In the US, you need a private pilot's license with a multi-engine rating and a tailwheel endorsement. It's unusual time because every hour you fly in an AirCam, you're logging tailwheel time and you're logging multi-engine time.
So Phil, can you tell us a bit about the safety of the airframe? So like the engines?
The 2 engine systems are separate. We have 2 separate fuel tanks, separate fuel pumps, separate auxiliary fuel pumps. The 2 engines are independent, right? So if you had a problem with one, it shouldn't affect the other one. But some of the other things that really make the AirCam different from other piston twins, you have the engines, they're very close together, right? So the isometrical thrust is minimized. It really makes it much easier to handle on one engine. Huge vertical stabilizer, right? So that gives you control of the airplane right down to stall speed. So VMC is pretty much at stall. Then you have the fact that with the Rotax engines and the prop we use and the speeds that we fly at, if you shut an engine down, the prop stops. So that negates the need to feather an engine. Then you have automatic mixture control, no cowl flaps, and the gear is fixed on the land plane. So you basically narrow your checklist for an emergency down from typically 30 items on most piston twins to push the throttles forward and fly the airplane, right? Because the engine's gonna stop. You don't have much isometrical thrust, you don't have cowl flaps, you don't have mixture, you don't have prop controls, you don't have gear. So it's gonna fly. And the problem with most piston twins is they will fly on one engine if they're properly configured. But what happens if you lose an engine shortly after takeoff? You're so far from being configured. I mean, you've got to identify which engine it is, you've got to shut it down, you got to identify it correctly, shut down the right one, get it feathered, you got to get the gear up. You got to make sure your flaps are up. You got to make sure that the mixture is full forward, props full forward, cowl flaps are closed on the bad engine. And if you do all those things, it will fly on one engine. But it's kind of impossible to get all that done right after takeoff. So you're basically descending pretty quickly. Whereas we can fly out of that situation. It's a tough situation for a conventional twin.
Yeah, and you can identify really quick because all you got to do is literally just look backwards.
Well, you can look backwards, but even if you don't do that, if you just keep the airplane straight and shove both engines forward and just focus on flying the airplane, it will continue to fly. And so the pilot workload is so much less than in a normal twin, and that's where a lot of the safety comes from.
All right, so what sort of fuel are we running on? So there's two different engines.
Well, with the 912 ULS, which has been the most popular engine, also with the 912 IS fuel-injected engine, in the US it's 91 octane. We use an AKI rating here, right? So it's basically premium auto gas with up to 10% ethanol that we can use. We can also use standard blue 100LL avgas. And then there are some other fuels like Swift UL94. Probably we expect the new Swift R100, which is an unleaded replacement, will also work. So really we can run on just about anything that any airplane could operate on.
What about the fuel usage? How much fuel are we using at cruise?
We're typically burning about 3.5 gallons an hour at high cruise per engine. Wow. So 7 gallon an hour total, and that would be flying from 85 to 100 miles per hour in that range. And if we slow down to 60, then our fuel burn is going to be probably 4.5 gallons an hour.
Wow, so it's very fuel efficient too for a twin.
Fuel is really not a factor. The fuel injected engine's about 20% more efficient. So that at high cruise, instead of 7, it burns about 6 total.
All right, so Phil, tell us a bit about the float. So how much chop can it handle, and like how much of the float is actually in the water?
Well, the floats will sit right about like this. Typical displacement for an AirCam float is going to be 2,200 pounds of displacement. That's what these are, and that just works well. This is a Montana amphibious float. A lot of them have Claymore amphibious floats, and then there are 4 or 5 other different types of floats that they've been mounted on successfully. The takeoff is very short, and part of that is because we're designed to fly on one engine. So when we have 2 engines, we have so much thrust, and that just equates with the big wing to a very short takeoff distance. We'll take off looking at the weeds in front of us, and I'll be with a customer and they'll say, whoa, you know, you're going to take off here? I'm like, yeah, no problem. And boom, literally 10 seconds is a pretty typical takeoff run.
Wow. And what about for the wheeled version as well? Like, what's the takeoff distance for that?
Sure. Well, the wheeled version will take off shorter because you do have less weight and less drag. But it's really ridiculous how short it can take off. So
you're basically pushing the limits of being a helicopter.
Well, if you have wind.
Yeah.
Yeah, because the stall is down around 35 knots, right? So the plane can fly very slowly. We operated out of that 600-foot strip, 200 meters or so in the Congo, and that's really, I can operate out of that quite easily.
All right, so Phil, this just looks like the perfect all-round aircraft. It's got floats, wheels, everything. It contributes to your multi-engine license. How much are we talking?
If you wanted to build a new kit, if you buy the airframe package, the engine package, a nice avionics package, and then some accessories, nav lights and landing lights and that sort of thing, you'll be at about the $200,000 US dollar mark to get everything you need to get the airplane in the air. Floats, depending on whether you build a kit or buy finished floats, can range anywhere from $20,000 to probably $60,000.
And who's the typical customer for an AirCam? Is it like commercial use? Can you use it for joy flights, personal?
Well, the typical customer is just using it for fun. It is so much fun. I mean, when you're in the front seat of an AirCam, it's all behind you. Right? Those pusher engines are way back there. The wing is behind you. There's no high wing or low wing visibility thing. There's no wing, right? And it's tandem. So you can look down and around. I mean, the visibility is extraordinary. I tell people it's like being on Aladdin's magic carpet, you know? It really is that cool. People buy them because it is such a cool ride. It is so much fun. We also get a lot of older customers who maybe, approaching the end of their flying career, and they see that. And the AirCam is so easy to fly, so simple, the redundancy. So they'll keep an AirCam as they get rid of more complicated airplanes and just keep flying for as long as they can in that super fun airplane. Airline pilots make up a big percentage of our owners. They kind of are used to system redundancy. And I put airline pilots into two categories, right? You got the ones that love to fly, and then you got the ones who just do it for a living. They're doing something different, right? The ones that really love to fly, they like the AirCam.
All right, so Phil, what do we actually have in here?
So these are the parts that go into an AirCam kit. We have all sorts of AirCam parts here when we get an order either for individual spare parts or for an AirCam kit. Our crew goes and packages it all up and ships it out, creates it.
So it's quite easy just to get different parts?
Well, there's 22,000 parts in an AirCam, so it's quite a process to get all the parts together to have them ready to ship. One of the things that makes us different from some other kit manufacturers maybe is that we do stock the parts, right? And we typically have anywhere from maybe 5 to 30 kits worth of parts of any individual part. Some of the assemblies might take 3 months to make. Yeah. Some of the special parts that we have to have made might take 6 months. So we can't wait for just-in-time manufacturing. That won't work. So we end up carrying quite a bit of inventory. It's beneficial to our owners. If they need something, we usually have it.
All right, so we're at the AirCam factory. So are you guys actually making the parts here?
Yeah, we do manufacture a lot of the parts here. So we use a combination of outside sourcing and manufacturing right here because it's fairly low volume. There's a lot of hands-on. Some parts are specially made for us by other companies. Most of the CNC cutting of like sheets and that sort of thing, we job out. Those CNC machines, they change so quickly, the computers, that 4 to 6 years, it's obsolete, really, if you want to have cutting edge. We will take a local company that specializes in just cutting CNC sheet, for example. We'll have them cut our sheets for us, and then we will form them here. So when we get the blank 2024 T3, say 25,000 or 32,000 sheets with all the holes burnt in them and cut, we have our own forming equipment. So we'll actually stamp the parts or roll them or whatever they need to make them a final shippable part. I can show you some of the parts if you want. Like this is a composite part right here, and you'll see they're really high quality. This is the top cap to the vertical stabilizer, and you can see that it's really nicely laid up. There's no extra resin in there.
So you literally have off-the-shelf parts?
Yeah, and but this is what you would get in a kit, trimmed, ready for paint, very lightweight. Feel the weight of it.
Yeah, very light.
Yeah, and there's a lot of composite parts, and those are all made for you. Here's a leading edge part. That's going to be for a rudder. So this is one of the ribs on the leading edge of the rudder, and this is the way it will be. So I talked about the blank. So the blank would have been cut at another company, and then it would have been formed here in our press. So these are actual parts. Another rudder rib. That's the way the part would come to the customer. It's really more of an assembly process for the customer.
So you could almost come here like it's Home Depot and just pick out the part needed.
Yeah. And then all of the steel parts are going to be made. Any welding that needs to be done is done here. We have a full-time welder in our own welding shop. And then the steel parts are typically either plated or powder coated. So there again, these are actual parts that would go in the kit. Here, there's a lot of machine parts. Here's a flap arm. Okay, so that's going to be a part that was, again, CNC cut outside, came here. It's got a number of bends here, here, here. That's all done here at our shop. And then it's sent out, and this one was anodized in black. When they come in, they'll be stamped with the date that they were processed. This one in 2/4/25, they had a whole bunch of them. And sometimes we will make a lot of a particular part that's maybe difficult to make. We might make a couple of years worth of parts at in one run because it's just much more cost effective to make a lot of them than just to make a few. This is a 07 and an 08. This is the 07, so it goes here. But again, you're not, when you're building an AirCam kit, you're not really fiddling around making parts. It's like I say, it's more of an assembly, and I think that's one of the things that we're kind of famous for is a really nice assembly manual with great detail and very, very high quality parts.
And do you guys offer like a factory build assist program?
We do offer part of that. So we offer the fuselage as a finished fuselage option that's primed and ready for paint. That is about a third of the build process. We can still meet the US 51% rule with that fuselage pre-riveted. And so that saves about 400 hours of time for the customer if they buy that option. If they want to go beyond that, we have private groups in the US that have helped a lot of customers with their build.
How long does it normally take to build a kit?
If you were to build the standard kit, it's about 1,200 hours.
Yeah.
And of course, if you want to putz around, you can spend a lot more than that. And then we have customers that are fast that have done it in less than that.
Everything you see here is made in the USA, so quality.
Few exceptions. Our wheels and brakes are made by Behringer. Of course, they're coming from France. And the engine packages are Rotax packages. Those engines come from Austria. With those two exceptions, just about everything else is made in the USA. Even the wing sail fabric, which we could have made in China and save a bunch of money, they're made in a US high-performance sail shop. This is a part that holds the battery up front, and it's made of 4130 steel. It actually is there to protect your feet. So if you were to land an AirCam off field and hit a fence or a small tree, your feet are up front, right? So this steel bar goes in front of the rudder pedals to protect your feet if you were to shatter the...
So you guys have really thought of just everything.
Yeah, well, not everything, but as much as we can. And when you get this, again, this was formed here out of 4130. These pieces were stamped here, and then there's a fixture, and it's all welded together, and then it goes off and gets powder coated, and this is the part that you get in your kit. This is the tail spring for a Gen 3 AirCam right here. It's a special alloy made just for spring steel, and it's a new design, which is part of the gross weight increase for the Gen 3. It's really rugged tail spring. Of course, it's completely finished, bent, heat treated, and it's powder coated when you get it. This is our machine shop. So in here, we talked about that combination of CNC work and hand work that we have to use to get our parts the way we want them. So this is where that hand work is done. You've got a roll machine where all the leading edge wing skins and fuselage skins that get their rolled radiuses put on them. This is an old press that we use to make different bends. And then we have fixture. These are all tools that are made for different parts on the AirCam, fixtures here for different tools. So we have this big press out here, and this press is what makes all these tricky pieces. So, you know, when you have a part like this that gets formed, so you have the blank, this is a rib for the fuselage. This one they boogered up because they put the pins in the wrong place. So it's scrap, but that would go on this press. This press is capable of exerting 800,000 pounds of pressure on the die. And what we do with it is called hydroforming. So we have a 6-inch block of urethane rubber in that bed up on top. That's it's all steel that holds that rubber in place in the top section. And then they're going to put the die on there for the particular part, put the blank on top of it, and then when they press it, it forms the parts. Of course, we have tooling for every single part on the airplane, like this. And you can see these, like this will end up with a 90-degree bend, but because we're bending in the heat-treated state, we overbend, and then there's a spring back. That's all compensated for. Here you can see sheets. Now, we talked about, this is one that was dented, so they're not using it, but so these come from suppliers where they've actually cut the sheets with a CNC machine. You can see all these different parts here. They're waiting to go onto the press and be formed. They just pull the fuselage out of here to get it out to ship to a customer, but these are the fixtures that allow us to assemble a fuselage. So even when you buy the standard AirCam kit, when you get the fuselage, it almost looks like it's done. And that's because we've taken all the parts and we put them together on this very precision built jig. And used temporary rivets to spot them together. So when you get your fuselage, it looks like it's done. All the parts are there, but it's not. It's just fixtured together so that you don't have to make any fixtures. And then you're going to drill all the holes out to the correct size, and then you end up taking it apart and deburring it and priming it and then putting it back together. But because you drilled out the holes, the rest of the holes, to the correct size with our fixture rivets holding everything true, it just goes back straight. We have a fixture for the vertical stabilizer. They go out the same way. They fixture it together. And then these are all parts, again, that go into the kits. So you have skins for the fuselages. You have more tooling back there. There's a whole rack with all kinds of little fixtures and tools. These are longerons that go into the kit. You have this part here. This is pretty cool. This is a trim tab for the elevator. And Mr. Snappy, I'm going to give this to you. You go ahead and hold it.
Oh, wow. I would not expect a trim tab to be that light.
Yeah, so aluminum can be very light. And one of the other advantages of aluminum over a composite is it's very easy to make it consistent. But this is made of 16 thousandths thick 2024 T3 aluminum, right? And you end up with a very light part. But it's a tricky part to make. Again, this is made out of one piece of aluminum, even the end bends. How do you do that? How do you make that and get, so we do that here. That's a bit of magic. And then that's the way the customer gets it. They just put a rib in here and rivet it together, and so pretty much done. Some kits you might find you get a rack of parts and you got to like gnaw them apart and really clean them up and finish them. You're going to find our parts are pretty nicely finished.
It's just an easy jigsaw puzzle to put together.
You know, I think it might be easier than some jigsaw puzzle to put together. You can see, again, fuselage skins, vertical stabilizer ribs that are here. Over here, more fuselage. These are the bulkheads for the fuselage. Lightweight, right?
Yeah.
So the fuselage is a monocoque construction design, so the parts are flimsy until you rivet them all together. And then it becomes quite stiff.
Oh, it's just pick up the whole fuselage just by hand.
Yeah. On the Generation 2, the aft bulkhead was formed out of a single piece of aluminum. On the Gen 3s, we've switched to a piece of billet. So this was replaced with a single piece. And this was a tricky piece to design because of the angles. You can see nothing is a right angle. It's a tricky piece. We call this the pie plate. Front and a back section to the main enclosure. And as you guys already know, we offer a full enclosure option for the AirCam.
Yeah, so if you buy an AirCam that has like air, like you don't have a canopy, can you still fly maybe open air with the canopy version, or do you have to take them off?
Any AirCam can be retrofitted to have a full enclosure. And once you retrofit it, you can go back and forth. It takes about 30 minutes to go from fully enclosed back to fully open. If you're flying in cold weather, it's really nice to have the full enclosure, and it doesn't really take away that much because it's all glass, so you really still have the same visibility. So it's been a very popular option.
All right, so Phil, we're in another factory of yours. What do we have here?
This is actually our R&D center, and here we have a fuselage that we beat up all the time, torturing it and doing different nasty things to drop tests and the like. So we're right now in the process of getting approval to fly in Switzerland. They have been asking for some special testing that they want to see to give us approval there. So we're about to do a test for them. And hopefully we'll have an AirCam flying in Switzerland very soon. That involves a special drop test that we're going to do for them.
So when you say drop test, what are you talking about? Are you going to like throw it off a building?
Yeah, no, we're not going to throw it off the Empire State Building and see what happens. No, so we did elaborate drop testing initially for the Gen 2 and the Gen 3. And it's kind of a strange thing. We did not incorporate spin-up loads in our drop testing because our touchdown speeds are so low. If you touch down at 70, 80 knots, I mean, it's a big deal, right? But with our small wheels, typically the way most AirCams are equipped, and our low touchdown speeds, the spin-up loads just haven't been a big factor. But the Swiss want to see the spin-up loads incorporated. So that means we have to redrop the airplane, and we'll actually build a angled platform that push the gear back as the plane hits the ground.
Oh yeah. Wow.
To basically mimic what the spin up load as the plane touches and you get the tires up to speed, it pulls the gear back a little bit. So we're going to do that drop test for them and show them, hey, it's
all right,
really not an issue. Oh, there's only 320 AirCams flying and none of them have ever had an issue with spin-up loads on landings. So we kind of know it's not a thing, but we have to prove it to them. Yeah, so you can see this one is one we've used for testing over the years. And if you look here, basically they're reconfiguring it back to a Generation 3. And this is interesting for you guys too, because one of the differences between the Gen 2 and the Gen 3 is you have these footwells back here, and in the cargo bay, which is this area of a Gen 2, you would not have these footwells. This would be flat. And then you also have these special attachments for seatbelt harnesses. In the Generation 2, there's big plates and reinforcement back there. And then the landing gear bulkhead is much more beefy on the Generation 3. Again, it's got stronger landing gears. It's made of a more sophisticated alloy. It's a larger diameter gear to accommodate those 1,900 pound gross weights. And so this one was set up as a Gen 2. They're reconfiguring it, which is a tremendous amount of work. But there you go. We're doing it, and we're going to conduct that
constantly
test.
Innovating. So there's also like easy access on the aircraft too. Like, see, there's no nose cone.
Yeah, the nose cone can be removed in a matter of minutes, and that gives you complete access to all the avionics. It's like at workbench height. It makes it really easy to install the avionics and to service them. The AirCam is unusual for a twin in that when you remove the wings, the engines can remain on the main airframe. Okay, so you see here, you've got two engines mounted on the center section, and the wings have been removed. If we put it in a sea freight container, like if we ship one to Australia, we do usually pull both engines. You have to pull at least one of them, I believe the left one, to get it to fit in the container. But the engine packages go back on very easily. The engine package can be removed. There's two bolts here and one bolt here. And then you just have to disconnect the fuel line, the throttle cables, and the electrical connections, and the whole engine package can come off. And we just bolt them down to a pallet and put them in the sea freight container. It's very easy to get them off and then get them back on. I mean, the coolant can stay intact, the cooling system, the oil system, it's all still with the package. And so it's fairly easy to ship one in a sea freight container, 40-foot sea freight container.
These AirCams, they just keep getting easier and easier to put together. I'm from Australia, right? Easy to get one down there, right?
We actually just shipped one to Australia about a year ago.
Can you fly from the second seat, or do you have to fly from the first seat?
You can fly from the second seat if there's someone up front, but you have to have someone in the front. So the real thing is, if you're going to solo an AirCam, it must be from the front seat. And that is to balance the engines.
The person in the front seat, do they also have to have a twin engine rating?
But no, the pilot can be as long as there is someone up front, the pilot can fly from the middle seat. The middle seat has full controls. Brake, toe brakes, rudder, aileron, elevator are all there.
Phil, obviously this is a very unique aircraft and people might want to learn to fly one if they're going to buy one. So how do you train people in these aircraft?
It's a fairly easy airplane to fly. Typically they would come to us, they'd already have a multi-engine rating, already have a tailwheel endorsement, and then we'll do what we call transition training with them. And that could be anywhere from an hour to, it might take 10 hours, depending on the experience that the pilot has.
So whether it's like float training or just wheels?
We do both. In the case of the float training, we have kind of a unique thing we offer. We actually do the multi-engine sea training and they can get their rating in our airplane. With the multi-engine land rating, the US FAA will not allow us to do that. They say, hey, you got to do that in a certified airplane. But they made an exception for us with the multi-sea rating because it's so hard to find an airplane that you can do. I mean, you're going to use a Grumman, Goose, or Widgeon, or some very expensive, very old airplane to try and get that done. So they made an exception, and you can actually get your multi-sea in an AirCam here at our shop. Make
sure you come down to Sebring, Florida and see one of these aircraft. They're absolutely amazing. Out of all the aircraft I've ever seen, these are some of the nicest aircraft, especially for float aircraft.